We're going to talk about bandgap and semiconductor current carriers, which will help us understand how current is produced in a semiconductor. We'll remember that all atoms consist of neutrons, protons, and electrons, except for a normal hydrogen atom, which doesn't have a neutron. Using the Bohr model, we can visualize that an atom has a central nucleus consisting of protons and neutrons that is surrounded by orbiting electrons. The orbits surrounding the nucleus are grouped into energy levels known as shells, and the outermost shell is called the valence shell. The valence shell of an atom represents a band of energy levels, which is why it's also called a valence band, and valence electrons are confined to that band. When a valence electron gains enough energy from an external source, it can escape from the valence band and goes to the conduction band. The difference in energy between the valence band and the conduction band is called bandgap. It is the amount of energy a valence electron must possess so that it can jump from a valence band to the conduction band, wherein the electron is free to move throughout the material. If the band gap is really big, electrons will have a hard time jumping to the conduction band, which is why a material may have poor conductivity. Let's try to examine the energy diagram of three types of materials used in electronics and discuss the conductivity of each material based on their band gap. As we can see, the band gap between the valence band and conduction band in an insulator is really big. This is why it doesn't conduct current. The band gap in a semiconductor is smaller compared to an insulator and allows a valence electron in the valence band to jump into the conduction band if it receives external energy. In a conductor, like copper, there's no band gap. Actually, the conduction band and valence band overlap, which means the electrons can freely move into the conduction band. This is why you may hear the electrons in metal referred to as a sea of electrons. They're just floating around. Now that we know more about band gap, let's discuss the two types of current carriers in a semiconductor, free electrons and holes, and see how they produce currents in a semiconductor. Atoms may combine to form a solid crystalline material through covalent bonding. For example, a silicon atom covalently bonds with 4 adjacent silicon atoms to form an intrinsic silicon crystal. Intrinsic because it doesn't contain impurities, and a crystal because there is a pattern in how the atoms are connected. At room temperature, intrinsic silicon crystal gains enough heat energy that enables some of the valence electrons to jump into the conduction band, becoming free electrons. When this happens, vacancies are left in the valence band within the crystal. Now these vacancies are known as holes. Now if we put a voltage source across an intrinsic silicon material, the thermally generated free electrons in the conduction band will be attracted to the positive end of the voltage source. They will move towards the positive end, and this movement produces current in the material. This type of current is called electron current. While electron current happens in the conduction band, the other type of current, hole current, happens in the valence band. Remember that as valence electrons jumped into the conduction band, vacancies or holes are left in the valence band? Electrons that remain in the valence band can move into a nearby hole when it receives a small amount of energy. This movement produces a current in the valence band called hole current. Though the current is produced by valence electrons moving into a nearby hole, it is called hole current so that it won't be confused with the electron current produced in the conduction band. In this video, we learned about band gap and the current carriers in a semiconductor. We examined the energy diagram of the three types of materials used in electronics: insulators, semiconductors, and conductors, and briefly discussed their conductivities. We also talked about the two types of semiconductor current carriers, free electrons and holes, and mentioned how they produce current in a semiconductor material.